In order to run Simulink, you have to first run MATLAB, and then from the menus, you click on Simulink library shortcut. I have already done that. This is what you see from the Simulink. In general, Simulink is the block diagram language of MATLAB. So instead of writing scripts and M files, using if then else and all sort of like MATLAB commands, you can just connect the blocks together to create a system, and then you can simulate that system and you can monitor the outputs. That's what Simulink is provided for. You can see the libraries on the left pane. There are default libraries like continuous or discontinuous blocks or the sources, and there are additional toolboxes that you can add or like delete based on your need. For example, DSP system toolbox that has all the blocks for the DSP systems, or image acquisition toolbox which has all the blocks for any sort of image acquisition system. Let's start with the simplest model. In order to create a new model, you go to File, New, and Model, and you see a blank model is open here. Let's say I want to create a simple model to add a sinusoidal input with a step input, and then after adding them together, I want to monitor the output of this summation. So I'll start with sine. So I'll search sine. You can of course go to sources, but it would be easiest if you can search the keywords. For example, for sinusoidal signal and input, I'll just search for sine. And when I say search, you see that the sine like wave is here, the block. So I'll just simply click and drag it into the model, and then I can double click on the sine wave, and you can see that the parameters for amplitude, bias, frequency, phase, sampling time, and everything is here. Let's keep the amplitude, and I simply change the frequency to 20 radian per second. And in order to get a smooth sine wave, it's better to not have the sample time as 0. Let's keep it to a small number. I just put it to 0001, and then I'll say OK. And then I need another input, which is the step signal. So I'll just search for a step, and a step block is the first one. I'll just simply drag it. I'll double click to see the parameters. A step time is the time that the step signal is going to jump from 0 to the final value, which is set to 1. So there is an initial value, final value, and a step time is the time of jump. So let's change this to 0.2 second, and I'll say OK. It means that this jump from 0 to 1 is going to happen at 0.2 second. Then I need to add these two outputs together. So I'll search for sum, and the first block is the summation block. There are two inputs, so I can just connect these two to the summation block. And if you need more than like 2 input, you can just add more plus signs here, so to give you more inputs, or you can add minus sign, so it would like do the plus, or like subtraction or summation. Now I need to connect this output to something that I could monitor. So for that, I'll search for scope, which is the monitor. So I'll grab the first block here, which has one input, and I'll connect the output of summation block to the scope. And now it's the time to do the simulation and see the output. Here the simulation time is 10 seconds, which is high. I'll just put it for 0.5 for the frequency of the sine wave that we already set. And this is the run shortcut. So you run the simulation. You can name it first. So let's name it to, for example, test 1 and then save it. So test 1 is the name of the new model. I'm going to run it, and then after you hear the ding, double click on a scope, and then you can see the output of the simulation. You can change the uh, scope size. So you can see that we had a regular sinusoidal for half a period, and then at point 2 the step signal became affected, and then it changed the amplitude, and now you have a new signal. You can right click on the plot and say auto scale, so it would be a better view. Auto scale is helpful in when you're working with scope, so try to use it as much as possible. So this is a simple model that we created, and we ran the simulation. You can see the simulation time is 0.5 and 0.2 was the time that the step input came to effect. So let's do another model to create a system. You know that normally a system is recognized by its transfer function. So we want to know how we can use Simulink to implement a transfer function. So I'll simply just mark and delete these parts. So I keep the step function. Why? Because you need to and then like find the behavior of system for a step function or any sort of inputs. So I'll just keep the step block here. What I need to do, I'll just search for transfer, and these are the blocks that just came up, and I can just simply drag this one, which is what I need basically. The transfer function is shown as 1 over s plus 1, which is the Laplace representation of this transfer function. If I double click, you see that the numerator is 1. That's why you see only 1. And the denominator coefficients are 1 and 1. That's why you see s plus 1. So let me change it to 1 and 2 here. And let's change here to 1, 2, 3. And let's see what happened. You can see that the transfer function changed to s plus 2 over s2 plus 2 plus 3 because my coefficients for nominator was set to 1 and 2, and the other ones was set to 1, 2, 3. So whatever transfer function that you have, you can simply implement it here in this simple block, and then you simply connect the step function to see the step output. And let's change this to 2 seconds for now, and let's run it, and then you just do the step. You see that it was not like, let's do the auto scale, and then you see the 0.2 is actually coming from the 0.2 time that we set for the step function, and then this is the behavior of the system to the step input. As you can see at 2 seconds. If you want to have more simulation time, you can just simply stop it and then change the simulation time to another time and do the simulation. So you can see that it's pretty much very simple to implement a system in Simulink. Another way of representing a system is through differential equations. So let's see how we can use Simulink to implement a differential equation. For simplicity here, we just consider a first order differential equation, dy over dt plus y is equal to 3x of t. And later we want to consider the input to be the like a unit function applied at t equal to second. So let's rewrite the equation in a way that on the left side I'm going to have only the highest order term of the differential equation. So you can see, for example, here if I rewrite it down here, I'm going to get this new equation. As you can see on the left side, I have only the highest order, which is dy over dt. Everything else is moved to the right side of the equation. So it means that if I can generate dy over dt, then I would be able to implement this one. So let's consider this line in my block diagram to represent y of t. which is of course connected to a scope to be monitored later. So now I need to search for an integrator. If I search int here, integrator block is going to be found. If I drag it on the model and connect it to the line, so I know that this line is going to be dy over dt. So dy over dt. And the reason is clear from the math. Why? Because if I integrate from dy over dt, it's going to give me y of t. So
now I need
then,
an adder. So
again,
here I
I
have to
need
search for
to
sum.
have
And if
a
you recall
summer,
from
like
previous time, I have
an
to
adder
get
to
my
connect.
adder here. Just you can simply delete and connect it back again. And I need a plus and a minus. So I'm going to change the last one to minus. So you see the sign was changed. And then I need to have my x of t. And x of t is a step function. So I'll search for step. It's going to give me the step block. And I need to be applied the input to jump to happen at time 2. So I'll change this to 2. And then I connect it to my adder. And I had to multiply this by 3. So I need a gain. So a gain block. So this is a gain block. The default is gain of 1. I have to change it to 3. And then this is going to multiply input by 3. And then y of t, I have to tap from here to here. So what I do, I'll just bring it here and tap it from here. So this basically indicates this block diagram. If we can review it again, it says dy over dt, which is the left side, is equal 3 multiplied by my input, which is ut minus 2, minus, because of this minus sign, this is going to be minus y of t. And this is y of t, if you recall from what we mentioned at the beginning. So all I need is just to run this model. Let's run it for, I would say, 5 seconds. See what happens. And this is my system. So you can see that before t equal 2 seconds, there was no output. Why? Because there was no input. Input only was applied as at t equal 2 seconds. And after that, I'm going to have an exponential behavior because a first order differential equation basically has an exponential behavior. So this is an overview of how to implement a system through the differential equations in Simulink. Some other useful blocks that I'm going to mention here, one of them is a block that you can use to multiply signals together or inputs together. So gain is multiplying just one signal by some constant number, but if you need to multiply signals together, just type prod, which is the product of the signal, and the product block is the one that you need. So it's got two inputs that you can multiply them together to achieve and to get one output. There is also sources library. A lot of useful sources could be found in this library. A step function was one of them that we already used. You can have a constant and change the constant number if you need a fixed number. Signal builder is a nice block. If you double click on it, you can just change it to any like arbitrary signal, any time, any like position, whatever. So you can create an arbitrary signal using the signal builder. Pulse generator is to create a pulse for from workspace if you want to read some data from like workspace, or if you want to read some data from a file, you use the from file block. Repeating sequence If you want to create an input which is a repetition of a sequence, sine wave, we already used it. Ramp is actually another input. So a lot of different things that you could find in the sources. There are continuous blocks that could be used a lot. The derivative, if you want to use integrator, we already used it to implement the differential equation,
And all sort of
like the
different
transfer
blocks that you can
function
search
and
in the
all
search
other
box
sources are the one that
if
you
needed.
could
I hope
basically
this
use.
tutorial was useful to you, and thank you for watching this tutorial.